Ever wonder where asteroids, these mysterious celestial bodies, come from? Well, let's delve into the depths of space and time to uncover their story. Born from the chaos of our solar system's formation over 4.5 billion years ago, asteroids are rocky remnants that have witnessed the birth and evolution of planets. These cosmic fossils primarily make their home in the asteroid belt, a region of space sandwiched between the orbits of Mars and Jupiter. But they're not confined to this celestial neighborhood. Some wander closer to home in near-Earth space, while others venture into the far reaches of the solar system. And they come in all shapes and sizes. Some are tiny, no larger than a pebble, while others are colossal, stretching kilometers across. Each one, regardless of size, follows its own unique trajectory around the sun. These rocky remnants floating silently in space carry within them the potential for tremendous energy release. Their seemingly quiet existence belies the dramatic influence they can have on planetary dynamics. What happens when an asteroid collides with a planet? It's an intriguing question that unravels a complex dance of physics. The dynamics of an asteroid impact hinge on factors including the asteroid's size, its velocity, and the properties of the celestial body it strikes. A small asteroid hitting at a high speed could release as much energy as a larger one moving slowly. Now think about the energy released during these collisions. When an asteroid collides, it's not just a quiet thud. No, it's more like an enormous explosion with energy levels that can dwarf nuclear detonations. This colossal energy release can lead to drastic consequences. It can carve out immense craters, send shockwaves rippling across the planet, or even trigger global climatic changes. From the microscopic to the global scale, these impacts can alter the very fabric of a planet's landscapes, atmospheres, and ecosystems. The energy unleashed in these collisions can have profound effects on our planet's landscapes and ecosystems. Our Earth has witnessed its share of asteroid impacts. Let's travel back in time to around 66 million years ago, when a colossal asteroid about 10 kilometers in diameter struck what is now Mexico's Yucatan Peninsula. This catastrophic event, known as the Chicxulub impact, triggered a series of destructive reactions, including massive tsunamis, wildfires, and a nuclear winter effect. The resulting environmental upheaval led to the extinction of about 75% of all species on Earth, most famously the dinosaurs. Fast forward to Siberia in 1908. The Tunguska event was a relatively small asteroid estimated to be about 30 to 80 meters in size, yet it exploded with the force of 1,000 Hiroshima bombs. The blast flattened over 2,000 square kilometers of forest, leaving a barren landscape in its wake. These historical impacts are not just tales of destruction, but they also provide us with invaluable insights. They help us understand the potential consequences of future asteroid encounters. For instance, they underline the importance of size and speed. The Chicxulub asteroid, although significantly larger, struck at a much slower speed than the Tunguska asteroid, yet both had devastating effects. Studying these events also allows us to better comprehend the aftermath of impacts, from immediate local devastation to long-term global climate change. These historical events serve as sobering reminders of the potential havoc an asteroid collision can wreak. How can we spot a potentially dangerous asteroid heading our way, you may wonder? Well, the answer lies in the significant advancements in astronomical technology. These advancements have revolutionized our ability to detect and monitor asteroids that venture close to our planet, known as near-Earth asteroids. In this quest, ground-based and space-based telescopes play a pivotal role. With their high-resolution imaging capabilities, these telescopes can spot even small asteroids at great distances. They can track their movements, enabling astronomers to calculate their trajectories and forecast potential close approaches to Earth. The real game-changer, however, has been the establishment of dedicated programs focusing on these celestial wanderers. A notable example is NASA's Near-Earth Object Observations, or NEOO program. This initiative harnesses the power of multiple telescopes, both on Earth and in space, to continuously scan the skies. It's like having vigilant sentinels on watch, always on the lookout for potential threats. The NEOO program doesn't just spot asteroids, it also gathers crucial data about their size, shape, and composition. This information is invaluable in assessing the potential impact an asteroid could have if it were to collide with Earth. So while the cosmos may be vast and filled with uncertainties, our technological prowess gives us the upper hand in spotting potential threats before they become imminent dangers. With these initiatives, we can gain early warnings and insights into the trajectories of potentially hazardous asteroids. While most asteroids pose no immediate threat, what about the ones that do? This question sparks a fascinating dive into the realm of potential threats and the strategies we're developing to mitigate these risks. Asteroids hold the potential to unleash cataclysmic events. We've seen this in Earth's history, where impacts have triggered mass extinctions and reshaped entire ecosystems. Even small asteroids, upon entering Earth's atmosphere, can explode with a force many times greater than the Hiroshima atomic bomb. These are the sobering realities we face when considering the potential threats posed by asteroids. However, our understanding of these celestial bodies has grown exponentially, and this knowledge empowers us to devise strategies that could divert disaster. One such strategy is what scientists call deflection missions. These missions aim to nudge a threatening asteroid off its collision course with Earth, altering its trajectory just enough to ensure our planet's safety. This isn't about blowing up the asteroid Hollywood style, but rather about using physics to our advantage. Several concepts for deflection missions are being explored. For instance, there's the kinetic impactor technique, where a spacecraft is slammed into the asteroid to change its path, or the gravity tractor method, where a spacecraft is placed near the asteroid and the mutual gravitational attraction slowly alters the asteroid's trajectory. These methods require meticulous planning, advanced technology, and most importantly, time. Time is a crucial factor in asteroid deflection. The more warning we have, the better our chances of successfully deflecting a threatening asteroid. This underscores the importance of detection and monitoring initiatives, which provide us with precious lead time to act. As we navigate the cosmic neighborhood, the threat of asteroid impacts is a reality we cannot ignore. But armed with knowledge, technology, and a proactive approach, we can turn potential threats into manageable challenges. While the threat is not immediate, the work to protect us from potential asteroid impacts is ongoing and crucial. Every step we take in understanding these celestial remnants, every strategy we devise, brings us closer to ensuring our planet's safety in the vast, dynamic theater of space. The study of asteroids and their potential impacts isn't without its challenges. Predicting the trajectory of an asteroid is like trying to solve a jigsaw puzzle, with each piece representing a different variable. The size, composition, and speed of the asteroid, as well as the gravitational influences from other celestial bodies, all play a part in determining its path. But even with the most advanced technology, these variables can be difficult to measure accurately, leading to uncertainties in our predictions. Now, imagine trying to solve this puzzle while the pieces are constantly shifting and changing. That's the reality of studying asteroids. They're not static objects, but dynamic entities, interacting with the sun, planets, and each other in complex ways. And with each interaction, the trajectory can change, adding another layer of uncertainty to our predictions. But the challenges don't end there. Even once we've identified a potentially hazardous asteroid, what do? How do we prevent a collision? These questions form the basis of what we call planetary defense strategies. These can range from deflection missions, which aim to alter the asteroid's path, to more drastic measures like destruction or fragmentation. But each of these strategies carries its own set of challenges and risks, and choosing the right one requires careful consideration and planning. This is where the importance of international collaboration comes into play. Addressing the potential threat of asteroid impacts isn't a task for one country or organization alone. It requires the collective effort of the global scientific community. Organizations such as the United Nations Office for Outer Space Affairs, or UNOOSA, play a pivotal role in facilitating this cooperation. They help to coordinate efforts, share knowledge and resources, and develop unified response plans. In essence, the challenge of asteroid impacts is a global one. It transcends national borders and political divisions. It's a test of our ability to work together, to pool our knowledge and resources, and to act as one in the face of a common threat. Addressing the potential threat of asteroid impacts requires global collaboration and meticulous study. As we navigate these celestial threats, how can we keep the public informed and involved? Public awareness and education stand at the forefront of understanding the risks of asteroid collisions. The truth is, the more we know, the better equipped we are to respond to potential threats. Across the globe, initiatives are sprouting to inform and engage the public about the reality of these celestial catastrophes. These initiatives not only provide insights into the fascinating world of asteroids, but also instill a sense of shared responsibility. They make the complex science behind asteroid impacts accessible and understandable to everyone, from school children to adults. Moreover, these educational endeavors help us appreciate the immense work scientists and researchers undertake to protect our planet. They foster a culture of curiosity and respect for the celestial world that surrounds us. As we continue to explore and understand the risks of asteroid collisions, we all share the responsibility of safeguarding our planet.